Welcome to Daily Papers, the podcast where we break down fascinating new research papers into something you can actually understand. So, you're chatting with an AI. Maybe you're asking it for advice about a sensitive health issue or looking up some complicated financial information. You see that little padlock icon in your browser, so you think your conversation is completely private and secure.
Right. That lock means the connection is encrypted. No one can read the actual words you're typing or the AI's response. It's like your messages are in a locked steel box while they travel across the internet.
But what if I told you someone could figure out the topic of your conversation without ever opening that box? What if they could tell you were asking about, say, money laundering just by watching the boxes go by?
That sounds impossible and very creepy. But that's exactly what a new paper from Microsoft researchers Geoff McDonald and Jonathan Bar-Orr describes. It's called Whisper Leak, a side-channel attack on large language models.
It's a fantastic name, and it all comes down to something called a side-channel attack. This is where an attacker doesn't break the main security, the encryption, but instead gets clues from the side effects of how the system works.
Can you give me an analogy?
Think about your neighbor's apartment. The walls are thick, so you can't understand the words they're saying. But you can probably tell if they're having a quiet dinner party or a massive dance party just from the rhythm of the muffled sounds and vibrations. You're getting information from a side channel.
Okay, that makes sense. So how does that apply to a chatbot? The AI isn't throwing a dance party.
Not exactly, but it is doing something that creates a unique rhythm. When you ask a large language model, or LLM, a question, it doesn't just send the whole answer at once. To feel responsive, it streams the answer to you token by token, which you can think of as word by word. You see it typing out the response in real time.
Right, that familiar typing effect. Each of those little words or parts of words get sent over the internet in a data packet. Now remember our locked steel box. That's the encryption, specifically something called TLS. It locks the content of the packet, but an eavesdropper can still see two things: the size of the packet and the exact timing of when it was sent.
The size of the box and when it was mailed. And you're saying that's enough to figure out what's being discussed?
That's the core of the Whisper Leak attack. The researchers realized that different topics cause the AI to generate different patterns of words. A legal question might use longer, more complex words, creating a certain sequence of packet sizes. A simple factual question might generate a quick burst of short packets. These sequences of sizes and timings create a unique digital fingerprint for a given topic.
So they built a tool that could recognize these fingerprints. How did they test it?
They ran a huge experiment. They took 28 of the most popular LLMs from all the major providers. They asked them thousands and thousands of questions. Most were just random, everyday questions, what the paper calls noise. Think, where do the most rainbows occur? Or what are the best coding boot camps?
Just normal internet chatter.
Exactly. But mixed in with that noise, they asked about one specific sensitive topic, the legality of money laundering. They trained a machine learning model to look at the encrypted traffic and learn the unique fingerprint of a conversation about money laundering, distinguishing it from all the other random questions.
And did it work?
It worked terrifyingly well. For many of the AI models they tested, their attack could identify the sensitive topic with over 98% accuracy. It was almost perfect.
Wow. But in the real world, wouldn't there be way more noise? Like millions of normal conversations for every one sensitive one?
They thought about that too. They simulated a scenario with a 10,000 to 1 ratio of noise to target conversations. Even then, for 17 of the 28 models, the attack achieved 100% precision. That means every single time it flagged a conversation as being about the target topic, it was correct. No false positives.
That's the scary part. If an attacker is doing surveillance, they don't want to waste their time on false alarms. This sounds incredibly practical. Who would even be this attacker?
The paper calls them a passive network adversary. This could be anyone who can see your internet traffic but can't necessarily decrypt it. Think of someone on the same public Wi-Fi at a coffee shop, your internet service provider, or even a government agency.
And this isn't a flaw with one specific company's AI, right? It seems to be a problem with the fundamental way they all work.
Precisely. The paper calls it an industry-wide vulnerability. It's a consequence of wanting AIs that feel fast and responsive. That word-by-word streaming creates the very patterns the attack exploits. It's an emergent problem from combining streaming APIs with the properties of encryption.
Okay, so the big question, can this be fixed?
Yes, but there's no silver bullet. The researchers tested a few defenses called mitigations. The first is called random padding. Basically, you just add a bunch of random, useless data to every packet. This is like putting your tiny letter into a huge, random-sized box each time to confuse anyone watching the box sizes.
That makes sense. What else?
The second is token batching. Instead of sending the response one word at a time, the AI groups, say, 5 or 10 words together and sends them as one larger packet. This smooths out the detailed rhythmic pattern, making it much harder to analyze.
So instead of a detailed drum solo, the attacker just hears a single loud thump every few seconds.
A perfect analogy. And the third mitigation is packet injection, which is basically just sending a bunch of fake empty packets at random times to create noise and confuse the attacker's model.
So do these fixes work? Is the problem solved?
They help. Each one reduces the effectiveness of the attack, but none of them eliminate the vulnerability completely. And they all come with trade-offs. Adding padding and fake packets uses more bandwidth. Batching tokens can make the AI feel less responsive and a bit laggy.
So it's a balancing act between security, user experience, and cost.
Exactly. The paper also mentions that the researchers practiced responsible disclosure. They told all these AI companies about the vulnerability months before publishing the paper, giving them time to start implementing fixes. Some, like OpenAI and Microsoft, already have.
That's good to hear. So what's the big takeaway here?
For me, it's that online privacy is so much more complex than just having that little padlock icon. Encryption protects what we say, but this paper shows that how we say it, or in this case, how an AI says it back to us, can leak a surprising amount of information.
The whispers of our digital conversations can be heard even if the words themselves are secret. A reminder that in security, the side channels are sometimes the main event.